Okay, we're doing problem B. This. Christina has two arrays A and B, each containing non-negative integers. She can perform the following operation on array A any number of times. Apply a decrement to each non-zero element of the array. That is, replace the value of each element AI, the value AI minus 1. Determine whether Christina can get an array B from an array A by applying some number of operations. Okay. So, let's take the example 3, 5, 4, 1, and 3, 2, 0. Now, what does the problem say? AI minus 1. And if it's 0, you don't change it actually. So, yeah. If A value is 0, its value doesn't change. So you apply the operation once, A is equal to 2, 4, 3, 0. Then you apply it again, it becomes 1, 3, 2, 0, which is the same. Matches. Okay, so what's the idea of this problem? Well, you can simply just iterate through the entire list and check differences, right? But you have to watch out, because if an element from A is less than an element from B, then it's not possible, because then how can you subtract and get to a larger number, right? Or if A is 0, then there's no way, right? If A is 0, there's no way you can get it to B. So, yeah, the thing is here, you just iterate through A. You can use a data structure called a set, which is basically like a list, but like no repeated elements, okay? And then you can append this difference into the set, basically, okay? And then if you have like an edge case, or like, for example, B of I is 0, then you append it into a separate set, okay? You append the difference to a separate set. And then once you're all done, then you compare the two sets. But first you have to check if the set that contains the regular differences is greater than 1. If it's greater than 1, it's not possible, because then you have two different types of differences, and then you can't make A from B, because if one A of I minus B of I equals 3 and another A of J minus B of J is 4, you can't possibly create the same array, because that won't work. So, yeah, so then once you have that, then you traverse through the sets, okay, and check if anything from the 0 set is greater than the one from the normal set. And if that's the case, it's not possible, because then you need more steps to make the 0 one work than to make all the other ones work, which does not work. So here's the code in C++. So what I have here is read an input, and read an input. I have two sets, one sets st, one set 0st. I have a boolean, and I read an input. And then if b of I equals 0, you insert and then here, a of I. This is to check, make sure a of I is not like strictly less than b of I, because it won't work. Else works, it goes false, break, and then check the size. If it's greater than 1, it is more than one possible difference, it's not possible. Once it goes false. And then next, I iterate through this, how you iterate through sets. And then you check if y equals x, you break, and then you break, and if it still is true, then you see out yes, else is no. And this solution was accepted. Very cool. GG.